Hi, it's Derek from Tomcat Gas Training and welcome to this video on all you need to know about underfloor heating. So, let's get on with it then. Now, soon installers such as plumbers and gas engineers are going to have to take into consideration all the new changes what are going to happen to the building regulations at the end of this year. Now, it's going to be the biggest changes to Part L in the regulations since it was actually launched. And Part L has been designed to help the government reach their net zero target of carbon emissions by 2050. So these new changes will be coming into force soon and they will be affecting our new build houses first. So our government is opening by 2025, all our new build homes are going to be completely decarbonised. Now, the collective goal by the government is to actually get our new build homes to reduce its CO2 emissions by 31%. And that's compared to the houses we actually build today. How are they going to do it? Well, basically they're trying to say we're going to have air source heat pumps. But there are loads of other things we can do, and obviously with the new onset of hydrogen, hopefully gas boilers are going to be involved in that decarbonising, because hydrogen boilers will not be putting out any CO2. So what they're trying to do with the central heating system is actually get our flow temperature from the boiler or the heat source, whether it be a ground source or an air source heat pump or any other means, is to get this flow temperature lower than 55 degrees. But that's for space heating, not for hot water, because we still need to kill Legionella with our hot water, so we would still be looking at 60-65 degrees for hot water. So, how are we going to do that? Well, the perfect solution for a flow temperature of lower than 55 degrees in a new build house will be underfloor heating. So in this video today, we're going to look at everything you need to know about this underfloor heating and how underfloor heating is going to help reduce our CO2 emissions and keep all those gas engineers and plumbers in business. So if we do go to fully heat pumps, which I doubt in my opinion, but there, you never know, these things could happen. So if we do go to heat pumps and we do get a flow temperature of 35 to 55 degrees, then obviously underfloor heating is the perfect solution for heating your house, rather than oversizing your radiators, which you would have to do if you weren't using underfloor heating. So as radiators now are quite small in new build houses, we're going to be going back to double and triple size radiators to be able to heat our rooms to 20 degrees comfort temperature with a radiator. But underfloor heating, which is basically the full floor becomes a radiator, will quite easily heat our rooms to 20 degrees, for as long as they're installed correctly and commissioned correctly. So if you are having a heat pump fitted and it's not been sized correctly for the heating and the hot water, then you're wasting your time, because your bills are going to be far higher than they already are now with electric and gas, even though we've got this massive hike in prices at the moment because of this awful global thing what's happening at the moment. So reducing our flow temperatures to do our space heating is key to saving our CO2 and hopefully saving the planet, if we can do that. Now let's have a look at the major differences between a central heating system run on radiators and a central heating system with underfloor heating. So let's take the radiator first. So we have a radiator. It takes up a lot of space compared to the underfloor heating. Now, the coldest temperature with radiators would be floor level. That's why in winter your dog wants to get on the settee and the cat sits on the shelf somewhere out of the way because it's warmer. Because when you've got radiators, the warmest part of the room is at the ceiling level. So we're looking at a comfort temperature of 20 degrees at 1.5 metres off the floor. That's where your room stat goes, so it can be more accurate. But radiators shouldn't be called radiators, because they only give off 10% of their heat in radiant heat. The rest is convection. So the cold air comes up at the back of the radiator, travels up the back, then heat is transferred from the fins and the radiator, and then the heat comes up and travels upwards and then radiates around the room. We've got 65 to 82 degrees coming off this radiator. So a lot of heat is going into that radiator to be able to heat that room. Also, the air around the radiator is heated first. So you can get a lot of cold spots with radiators. So compared to underfloor heating is the opposite way around. The warmest part is the floor. So we've got 30 degrees at the floor. So the coolest part will be at the ceiling at 15 degrees. Again, we've got 1.5 meters up, we've got our 20 degrees. And this is giving off just radiant heat. And it should heat the room evenly because you're using the full floor as a radiator. So no matter where you are at one end of the room or the other end, it should heat up exactly the same. So they're the biggest differences. So from these two, you can see here, we can save 25% of our bill if we use underfloor heating compared to radiators, if we're using a boiler, and if we use those ground source or air source heat pumps, because the flow temperature will be a bit cooler from that, we can save up to 40% compared to radiators. And it's all about these flow temperatures. Obviously 65 to 82 degrees on a flow temperature, you're using a lot of energy compared to 30 degrees here on this underfloor heating. So they're the major differences between radiators and underfloor heating. So let's have a look at these different types of underfloor heating to see exactly what they are and how we install them. So, in a nutshell, what is underfloor heating? Well, basically it's a series of pipes laid in the floor. It's as simple as that. Now, traditional radiators are designed to last 10 to 15 years before they start to rust and corrode if the system's not been looked after. But underfloor heating is designed to last 5 times longer than that because it's got plastic piping. Now, the plastic pipe we actually use is PERT, which stands for polyethylene raised temperature. So the manufacturers of this plastic pipe say it is recyclable and we can use waste leftover stuff for other parts of the house. But it's still not as good as wading your old copper pipe, is it? But a copper pipe is never going to last inside a concrete screed, where the plastic pipe will do, if it's installed correctly. Now, underfloor heating can be paired with most floor coverings, including carpet. But you've got to make sure that the carpet doesn't have a TOG rating of more than 2.5, but we're going to look at the different floor coverings later. So yes, you can actually put anything you like over the floor as long as it complies with the manufacturers of the underfloor heating. Now, radiators with thermostatic radiator valves have more control over the heat of the house. The underfloor heating systems are a lot safer than radiators, especially if you've got 82 degrees flying around your central heating system, because that could be dangerous for the elderly and the young or the infirm. Whereas underfloor heating, you can't really have it more than, well, definitely not 50 degrees, because you'd be dancing on the floor, wouldn't you, like Michael Jackson, because it would be that hot. The floor temperature is that much lower. It's a lot safer for the people living in the house, as well as the environment. Also, underfloor heating is a lot better than radiators if you, like me, suffer with many allergies and asthma. Because what the radiators do is kind of collect the dust around the back of the radiators, and then through the aid of convection, they put that dust circulating around the room. But if you've got underfloor heating, I know the floor can collect dust, but you're going to be vacuuming it or sweeping it or whatever you want all the time. So it's a lot better for the polysick people like myself who constantly can't breathe because of dust and dust mite. And maintenance. Maintenance for underfloor heating is so much easier and cheaper than your maintenance for your radiators, because radiators can get bashed and damaged, whereas your underfloor heating is unlikely to get bashed and damaged. Also, like I say, the radiators are going to last, what, 10, 15 years where they're efficient, where underfloor heating could last, I don't know, 75 years and still be efficient as long as it is maintained. But you will still need some maintenance for the underfloor heating system, and you will still need to have it checked at least once a year, so it is still giving you the efficient system that you want. Let's have a look at these design considerations here then. Now, when we're measuring our maximum heat input for each individual room, what we do is we take our floor surface temperature, what we require, and then we take away the actual room air temperature. So that's basically our delta T, and then we times it by 10.6 for our watts per meter squared. Now, an example of this would be if our floor temperature was 29 degrees centigrade and our room temperature was 20 degrees centigrade. That would be 29 minus 20 is 9. Then we times that by our 10.6, and that gives us 95.4 watts per meter squared. Now, a good floor temperature would be between 29 and 35 degrees, but our maximum heat output for the underfloor heating is 100 watts per meter squared for concrete floor and 70 watts per meter squared for timber suspended floor. So no room should lose more than the above to comply with the building regulations document L. So that's the design considerations you need to do for the floor. But the good thing about this is the manufacturers of the underfloor heating system themselves will sort all this out for you. Now let's have a look at the installation of this underfloor heating and the different pipe layouts. Now, this is probably the most common type of underfloor heating system you'll come across, and this is the screed floor construction. So solid floors offer the best performance for underfloor heating, but you have to have the cement mixture at different ratios depending on how thick your floor is going to be. It is the ideal companion though for underfloor heating systems. The conductivity means you will have an even spread of heat throughout the whole of the floor area. During installation, underfloor heating pipes are laid on top of a layer of insulation, normally kingspan. This screed is then applied to the top, and it's shown there in the drawing. Ensure that the pipes are wrapped and held firmly in place, and a lot of the time this is done with plastic clips. The screed solid floor construction is a very cost-effective solution when you're building a new build, because insulation needs to go into the floor anyway, and so does the screed. So most of the components for this system are needed when building a new house. This next type of floor system we've got is what's called dry floor construction. Now, dry floor construction for underfloor heating systems refer to both timber and solid substructures. Now, this is mostly used when the subfloor has already been installed, because we're going to be using spreader plates, as you can see here in the drawing, to actually diffuse the heat upwards. So this can include a range of floor types for floating floors and timber batten structures, through to both acoustic and sprung cradle floors. Depending on the construction type of the property, underfloor heating modules are installed above the floor decking. The dry floor construction proves an effective underfloor heating system, ensuring the heat is spread evenly across the floors by the use of these spreader plates. The next system we're going to look at is a system where we're using the standard floor joist construction. So when it comes to installing an underfloor heating system to a standard timber floor joist construction, there are various options available. Battens are attached to the side of the existing joist, then insulation is laid in between the battens. The pipes are then set on top of the insulation and held in place again with these plastic clips. Then a sand and cement layer or a screed is laid over the top of the pipes. A thin layer of polyethylene membrane is then placed on top of the screed to help prevent the moisture from getting into the floor above. And then you can lay whichever floor system you want on top of the screed. The final system we're going to look at is the use of diffuser plates on top of existing joist construction. So heat diffuser plates are a good choice for timber floor joists or floating floors. First, a layer of insulation is laid between the joists, upon which a metal heat diffuser plates are set. The hot water underfloor heating pipes then lay in the grooves of the heat diffuser plates. Because of the metal conductivity, the heat diffuses rapidly across the plates, resulting in a more even spread of heat across the whole floor. You then can lay whatever system you like on top of the pipes. It's as simple as that. Now let's take a look at the three most common pipe layouts for underfloor heating. And we're going to start with the single serpentine, or what I like to call the snake. The simplest layout option is the single serpentine. In this design, a single pipe enters a room and then uses a zigzag motion to span the length of the room. The pipe then exits through the same entry points. Though this method provides an easier installation, it can distribute the heat unevenly across the floor. The hot water which enters the room gradually cools as it runs through the system. At the entry point, the system has a higher heat output and the room therefore becomes cooler at one end. This method is generally used when installing spreader plates. The second system is the double serpentine layout. The pipe enters and runs along the perimeter of the room before creating a zigzag layout, then running back on itself to create a contraflow. The cooled water therefore runs alongside the warmer water nearer to the pipe's entrance, allowing the temperature to even out throughout the room. This is an effective method to create a more even distribution of heat than the single serpentine, but we can't really use this when we're using our spreader plate system. This final layout we're going to look at is what they call the concentric layout, but I like to call it the snail. So this layout essentially forms concentric circles. The pipe is run around the perimeter of the room, then repeatedly tracked around the room, creating a spiral shape before reaching the centre. The pipes deliver the most heat around the outskirts of the room, where heat naturally escapes, while the centre of the room is heated by least by this system. As the heat loss is usually at its lowest in the centre of the room, the temperature across the room should average out. Once the pipe gets into the middle, then you just track back along the side of the rest of the pipework till you exit through the same way you've entered. Simple as that. An important component of underfloor heating when we're using screed is the edge insulation. So this edge insulation runs around the perimeter of the room, and this is to prevent side heat loss and to keep the heat contained within the zone. This also allows for a little bit of expansion of the floor system so it doesn't crack the walls. This perimeter insulation is normally installed at the same time as the kingspan going down in the floor by the same installer. But you can actually get this 20mm edge insulation from any builder's merchants. Now let's have a look at the distances we're going to be putting these pipes apart from each other, centre to centre. Now on average it's between 100 and 200mm. Depending on the floor layout, and also we might have 1, 2, 3 or 4 zones depending on the size of the room, because the maximum lengths of pipes we can have is up to 110 meters long. So the manufacturers will even send you coils at the right or near the right lengths for each room. So you might get a living room and there might be 3 zones in there. One where it's 100 metres, one where it's 80 metres and one where it's 50 or something like that, and they will send you lengths in accordance with that. Also, depending on the manufacturer of the underfloor heating system, it could depend on the diameter pipe they use, and it can range from 16mm down to 12mm. So make sure you get those right as well. But let's have a look at these distances. So first of all, we've got a red pen to show our flow. So we're going to come in to the building and the room, and we're running around the perimeter of the wall to about halfway of the room. That distance there will be 100 mil from the wall. Then we will come up the centre of the room, 100 mil in, and then we will be 200 mil apart as we're going around. And that'll become apparent in a minute. So when we get to the middle, we've then got a space to be able to come back out of the room with our return pipe. So these would be spaced 100 mil apart, and it all depends on the manufacturer on how far apart they want their pipes. So in that one, they're 100 mil apart. Now, obviously, if you have them 100 mil apart, then you've got more pipe and you've got more water in there, and you've got more heat. But they might want you to put them 200 mil apart. So there's the snail version. But if we have a look at the serpentine one, we come in with the flow and we run around again 100 mil, and we go 200 mil from that pipe, and we run it around the room, again being 100 mil off the perimeter of the room. And then once we get down here, we can take our return pipe and take it back out to our manifold. So like I say, the drawings from each manufacturer will give you all these measurements and you follow them accurately. It's unlikely you would do two different styles in a room, but some manufacturers do that, and I have done this, where one side will be the snail and the other would be the snake or the serpentine. Now also, we don't want to be running these pipes under things like kitchen units, because if you run this hot water under these kitchen units, it could actually cook any of the food what's in these units. And again, manufacturers will tell you how far apart you need to do this. But one of the things I have found out with underfloor heating where we haven't installed it is cold spots. So if you have things like bay windows, you've got to make sure the pipe goes into the bay windows, because again, you don't want someone moving from a nice lovely warm floor into a cold bay window. So again, you would follow into the bay window. So it's really important that the whole of the floor gets heated evenly, because your little tootsies will be able to tell whether we've got cold spots or not. So that's the distances. On average, it's about 200 mil apart, but depending on the size of the room and how much heat it needs, they might bring them closer. But they won't be normally closer than 100 mil, and they normally won't be further than 200 mil apart, but manufacturers will help you massively with that. Now, this concrete screed, how thick does it need to be? Well, if we take a look at here, we've got a minimum thickness of 65 millimeters for a dry mix to a minimum of 50 millimeters for a wet mix. But it does say best not to exceed 65 millimeters in a domestic situation. Now, if we make the floor too thick, it's going to use too much energy then to heat that floor up. And if we do the floor too thin, it's going to crack. So again, manufacturers' instructions for how thick the screed needs to be will depend on what your floor system you're going to use. So what about the drying time for this screed then? Well, basically most of them say 1 millimeter per day. So it could be around 80 days. But some of the other manufacturers say around 4 weeks. So you can also use the water in the system to help you with this drying time and speed it up. But again, it's so important that you follow the manufacturer's guidelines on this, and that you heat the floor up very, very slowly, but then not straight away after the screed's been poured. You need to be able to at least walk on it for a little bit. So that's your drying time. Also with this screed, we want to be pressurising the pipe within the system when we're doing our initial drying time. So on average it's 6 bar, or 1.5 times working pressure. But like I say, on average it comes out at 6 bar. And the reason why we have to expand this plastic pipe within the screed is to create an expansion gap. So what we'll do is we'll blow the pipe up to the 6 bar, we'll leave it for a certain time for drying, again guided by the manufacturer, and then the pipe will shrink back, leaving the original gap. And then obviously when the pipe heats up, it will expand, and it's got somewhere to expand, and it will stop cracking the floor or cracking tiles which have been put on top of the floor. That's incredibly important that we do this expansion. And again, I can't keep saying it any less, but you know, we need to be guided by the manufacturers for these underfloor systems all the time. So watch out for that one. And what about the insulation thickness? Well, if they say you're using the Kingspan, you need a minimum thickness of 70 millimeters thick if it's a ground floor, and 30 millimeters thick if it's over a heated space. I have known 25 mil go in, but on average we've used 100 millimeter thick Kingspan to take the weight. But you know, again, be guided by the manufacturer. So let's look at the manifold then. So what is a manifold? Well, basically it's the heart and brains of the installation. So this manifold will send the water from the heat source, which could be the boiler or the air source heat pump, and sends it around the flow loops. And it controls the temperature and how much flow rate actually goes through this flow loop. So let's take a closer look at it then. Start with a boiler. So we have a flow and return pipe coming from the boiler, which goes to the mixing valve right at the beginning of this manifold. Now this mixing valve is completely mechanical and it's automatic. Once it's been preset the temperature by the installer or the commissioning engineer, then that will make its mind up whether to send the return water back around the loop or back to the boiler to be able to be heated. Quite a complicated little bit of machinery which you don't actually do anything with once you've set it up. It then goes to the pump, and obviously the pump will then push it around the system. Depending on how many loops you've actually got and how long your pipe is will depend on the size of the pump, and again the manufacturer will sort all that out for you. So we then come across to the flow manifold. And on the flow manifold we have an isolation valve. We've also got one on the return, so we can completely isolate these manifolds from the system when we're initially filling the system, because we're not going to fill the system from the boiler, we're actually going to fill it from this end, but we'll get there in a minute. So at the top of this flow manifold we've got our flow gauges, and we've also got our flow adjusters. And again, the installer or the commissioning engineer will adjust the flow adjusters using the flow gauge. It's basically a little float in the water with a load of marks on them, and it shows you the flow rate. So it could be 1 litre a minute, 2 litres, 3, 4, 5, whatever the size of the loop is, whatever the manufacturer says needs to go through this, will go through the flow gauge and the flow adjuster. We've also got a temperature gauge, but we've got a temperature gauge on the flow and the return manifolds, because that's important that we know what temperature we've got going out and what we've got going back, because again, depending on the size of the floor and how they've designed it, it will be the temperature difference. So we come now to a pressure gauge. So the pressure gauge could be here, or it could actually be down here, or there could be two, because that's important as well. The pressure, what pressure do we have in the system? We've also got this drain and fill section which I was talking about before. Now what you would do with this is you would isolate the two valves here, you would then connect a hose pipe to here and connect a hose pipe to here, isolate all the other system when we're initially filling, and we would fill the water. These would be fully open and it would go all the way through the loop and out, and we would run that till we got clean, fresh water with no air in it. That's the best way of filling the system. If we come down to the return manifold, we have actuators. And basically what an actuator does is, it's a gate what turns on and off the flow. So it doesn't do it on the flow, it does it on the return. And these are connected to the room thermostats. So you could have 1, 2, 3 or 4 zones all connected to one thermostat. So they would all link back to the controller. We'll have a look at the controller in a minute. So these actuators are incredibly important, and they're like a motorised valve, electrically operated, and they will open and close depending on the temperature of what the room needs. So that's basically the components for this manifold. And where do we install this manifold? Well, that's the million-dollar question. We need to install this manifold pretty much in the centre of the property, so we get an even distribution of pipe through to the rooms, but a lot of the time that's not practicable. So we would install it with the help of the manufacturer and the customer to see where they want it installing, because it's actually a big piece of kit. But we also need to maintain it all the time, and we need to access it at all times. So it's important where we install it, because we don't want to waste lengths of tube all over the house just because we've installed it in one corner of the house. So try and install these manifolds in the centre of the property. That's why I originally called it central heating, wasn't it? Because the heat source was in the centre of the property. Anyway, that's manifolds. Let's now have a look at these controllers. Now, this is a controller. It's a very old one, I've had lying around for years, but if I take this cover off, you can see inside. So basically, everything gets wired back to this. So this is where the actuators go, and this is where the stats go. But the manufacturers actually give you a drawing which shows you where everything goes. You can't get it wrong. Now my advice to you would be, always buy one of these things. Don't try and be a cheapskate and not get one, because you'll struggle to wire it up otherwise. These are brilliant. So that every manufacturer will make one of these for their manifolds. So, make sure you get one. So that's the manifold, that's the controller, and we've seen the actuators. Now you can buy lots of different stats. You can buy mechanical stats, you can buy digital stats, you can buy radio frequency stats, you can buy hardwired stats. There's loads of different ones out there you can buy, but again, buy all the same equipment. For whoever does the manifold, buy all their gear. It makes it so much easier to install and so much easier to fault find if anything goes wrong. Also, we've got floor probes. So what do they do then? Well, basically you stick them in the floor as high to the top of the floor level as you can get, and what they will do is accurately measure the floor temperature. So if you've got a real wood floor, it will stop damaging that floor. Also, if you've got things like bathrooms, well, wet areas, shower rooms, where a air temperature stat won't work very well, you can put a floor probe in. Also, if you've got a towel warmer in there as well as the underfloor heating, you can put a floor probe in there to also give you an accurate reading on the floor, so you're not wasting energy. So, loads of different stats out there, loads of different ways of doing it. So speak to your manufacturer of the system to help you. Remember, you can even buy the things that work off your phone. So, that's stats. Now, let's take a quick look at these different floor coverings. Finally, ceramic and porcelain tiles, along with luxury vinyl tiles and natural stone flooring, are among the most efficient choices for underfloor heating. However, there are some floor styles that aren't suitable for underfloor heating. Engineered wood works well with underfloor heating if it has a thin profile, either 12mm or 15mm, without affecting the wood or impacting on the heat output of the floor. However, solid wood flooring cannot cope with the constant changes in temperature from the underfloor heating and is likely to become damaged and warped. Carpet with a thermal resistance of less than 2.5 TOG won't affect the efficiency of underfloor heating. With an 80% wool and 20% nylon carpet with a standard underlay will likely to be about 2.2 TOG at its best, so that would be the perfect carpet for underfloor heating. It's a good idea to tell the underfloor heating system designer the type of flooring that you're going to be using so that the pipe layout can be properly specified for the different types of flooring. Now, one of the floor coverings we need to be really wary of are rugs. You wouldn't think it, would you? A little bit of a rug on a floor can cause a problem. But what can happen is the heat can trap underneath the rug and could cause damage to the floor if the floor is made of wood or a laminate. Now, if we've got stone floors or we've got tiled floors, then the floor's not likely to get damaged. But if you've got a man-made rug, it could actually melt the rug. It can create that much of a heat problem. It can also stop your underfloor heating working, depending on the size of the rug, and can make your room cold. But if you are going to use a rug, make sure the rug is made of natural materials and its backing's probably Hessian or something like that, so it allows the rug to breathe and it doesn't trap all that heat underneath the rug, causing damage to the floor and causing your room to be cold, because that's not the idea of underfloor heating. So I know a lot of people like rugs, especially my wife. She loves a good rug. But if we did have underfloor heating, then you need to make sure you're buying a rug which is made of all natural materials. And the manufacturer of the underfloor heating allows you to actually use these rugs on the floor. So be careful of rugs. And the final thing about the floor is the moisture content in the floor itself. So depending on what the moisture is within the screed will depend on when you are allowed to install your floor system. Check with the manufacturer of the floor system what the maximum moisture content in the screed needs to be before they will allow you to install that floor system. If you don't take that into consideration, again, you could end up damaging the floor system. And that is the end of this video on all you need to know about underfloor heating. So as usual, if you've liked this video, please give us that old thumbs up or leave a constructive comment down below. If you've not subscribed to my channel, then please subscribe because it helps. But don't forget to hit that notification bell because you want YouTube to tell you when we're uploading videos. It could be any time. Anyway, all I've got left to say is thanks for listening, thanks for watching, and why don't you watch one of these other videos I've got here? Anyway, catch you on the next one, guys. Cheers.